Functional and nutraceutical significance of Amla. A review. This is printed in Antioxidants, April 22, 2022, printed in the National Library of Medicine, National Institute of Health. Abstract. Phyllanthus emblica, also known as Amla, is a tree native to India and Southeast Asia regions that produces fruits rich in bioactive compounds that could be explored as part of the increasing interest in naturally occurring compounds with biological activity. Thus, this review aims to highlight the nutritional aspects, rich phytochemistry, and health-promoting effects of Amla. Scientific evidence indicates that polyphenols are central components in fruits and other sections of the Amla tree, as well as vitamin C. The rich composition of polyphenol and vitamin C imparts an important antioxidant activity, along with important in vivo effects that include improved antioxidant status and activity of the endogenous antioxidant defense system. Other potential health benefits are the anti-hyperlipidemia and anti-diabetic activities, as well as the anti-cancer, anti-inflammatory, digestive tract, and neurological protective activities. The promising results provided by the studies about Amla bioactive compounds support their potential role in assisting the promotion of health and prevention of diseases. Introduction. Phyllanthus emblica, also known as Amla or Indian gooseberry, is an ephemeral tree belonging to the Euphorbiaceae family. Amla fruits are edible and mainly found in regions of India, Southeast Asia, China, Iran, Pakistan. Amla has an important role in the traditional medicine of India to reduce anxiety and burning sensations in skin and eyes, improving anemic conditions and favoring the health of the male reproductive system and reproduction, facilitate digestion, improve liver health, and also exert a tonic effect on the cardiovascular system. The fruit of P. emblica L is one of the most popular botanicals with a wide range of uses in the medicinal, cuisine, and cosmetic industries. This is the first tree to be produced in the universe, according to the ancient Indian mythology, and it's a great nutritional supplement with several medicinal benefits. Due to the abundance of phenolic compounds, emblic fruit could be regarded as a plant source for natural antioxidants and nutraceuticals or medicinal components. Consumers like emblic fruit because of its unique flavor and pleasant smell. In various animal and human investigations, Amla has been proven to have anti-hypoglycemic, anti-inflammatory, hyperlipidemic, and antioxidant activities. Amla is rich in antioxidants such as gallic acid, ascorbic acid, and phenolic acid compounds, and thus helps the body's immune systems and digestion. Thus, due to the increasing interest in the potential of P. emblica, this review aims to provide an overview of the nutritional composition, phytochemistry, and potential health benefits associated with the consumption of phytochemicals naturally found in Amla. Nutritional composition of Amla. Amla fruits are a relative source of carbohydrates that account for less than 70 grams per 100 gram of dry weight. Fiber is another relative component, as well as the contents of protein, minerals such as iron, calcium, and phosphorus, and fat. The variability of the composition of Amla fruit has been attributed to the cultivar in many studies. Another important component found in Amla fruit is ascorbic acid, vitamin C. The values between 1 93 and 720 milligrams per 100 grams have been reported in different studies that evaluated a different variety of amla. Although the optimum recorded daily intake has not been defined yet due to the emergency of new factors from modern society, many governmental health authorities around the globe established recommended dietary allowance minimum level to meet the need for a healthy person for a day that varies between 40 and 110 milligrams of vitamin C a day. Moreover, the Australian and China health authorities have proposed a daily intake of 190 to 220 milligrams per day. In this sense, a serving portion of at least 100 grams of fresh amla fruit, 2 to 3 pieces from any of the varieties, should suffice the daily need for vitamin C. Comparatively, pmc juice can present more vitamin C content than any other fruits, such as apple, lime, pomegranate, and some types of grapes. Additionally, other nutritionally relevant compounds found in amla fruits are vitamins A, B1, E, as well as calcium and iron. Phytochemistry of amla. Amla has been found to possess rich phytochemistry distributed in different sections of the plant, the fruit, leaves, and roots. The polyphenols comprise the main group of secondary metabolites, wherein several compounds belonging to phenolic acids, flavonoids, tannins, other phenolics, and derivative compounds that have been reported in different studies. Potential health benefits. Antioxidant activity. Diverse in vitro, in vivo, and human studies support the antioxidant activity of pmc components. In the case of in vitro studies, the content of polyphenols in the fruit has also been associated with high antioxidant activity, particularly with the capacity to scavenge free radicals. Other studies also reported that antioxidant activity of amla and the LDL oxidation assay method, that the additional amla polyphenols can also scavenge superoxide anion and hydroxyl free radicals as well as chelated iron. The observed antioxidant activity observed from extracts and isolated compounds from amla fruit using chemical methods has also been observed in more complex biological system that includes cells, animals, and clinical trials. In this case, the antioxidant defense system has an important role in the protection against oxidative damage in vivo. The system is composed of non-enzyme compounds and enzymes and superoxide dismutase. One example of the protective effects of amla fruit bioactive compounds against oxidative damage in the study carried out on hep G2 cells. The authors observed that the total antioxidant capacity was improved after 4 hours of exposure to different concentrations of extract. The peroxidation level was significantly reduced after 8 hours of exposure. And moreover, the antioxidant defense system was induced, including 12 to 24 hours of exposure to the extract. Similar results were reported in a study with raw 264.7 cells, and particularly for isolated compounds, ethyl gallate was indicated as the most efficient antioxidant to reduce oxidative damage. Cardioprotective activity. Hyperlipidemia is one of the major causes of cardiovascular disorder, but amla bioactive compounds may assist in the management of this condition. Different studies have been shown that protective effects of amla and/or its constituents against cardiovascular diseases. One example of this is a study conducted by Nambiar and Shetty, who studied the effects of amla juice on low-density lipoprotein oxidation. According to the authors, limited the uptake of LDL oxidation in the macrophages, and LDL cholesterol oxidation was reduced by 90%. Another study indicated that Amla polyphenols limited fibrosis formation in cardiovascular tissue of mice subjected to ischemia and repression. The polyphenol-rich extracts reduced metabolic changes caused by excessive fructose consumption in the animal models and reduced and even inhibited the enhanced mitochondrial and Brax expressions in the liver and regulated the BCL2. Antidiabetic activity. The compounds naturally found in Amla have also been associated with protective effects against diabetes. In an in vitro study indicated that the activity of the main phytochemicals found in Amla reduced the activity of key enzymes involved in glucose digestion, especially amylase and glucodase. The protective effects against diabetes have also been reported at the animal level. For instance, a freeze-dried Amla aqueous extract reduced the levels of serum glucose and triglyceride in diabetic long-eaten male mice. Clinical trials also support the health benefits of Amla for diabetic patients. For instance, daily doses of up to 3 grams of Amla powder extract reduced blood glucose levels in diabetic patients after 21 days of the trial. A similar outcome was reported where the diabetic patients, after consuming 10 grams of Amla powder once a day for 30 days. Amla bioactive compounds seem to play a key role in the management of diabetes, particularly in assisting in the restoration of glucose and insulin levels. Anti-cancer activity. Plant-derived polyphenols have been found to improve the protection against cancer in a variety of non-clinical and clinical investigations. Specifically, polyphenols inhibit oxidative stress, produce pro-inflammatory chemicals, prevent DNA damage, and increase apoptosis through various mechanisms. Particularly for the Amla extracts, the DNA fragmentation increased the activity of the upregulation of protein was observed, indicating activation of the death receptor pathway for apoptosis. The study indicated that Amla decreased the invasiveness of the cells, with no cytotoxicity was seen in normal lung fibroblasts. They conducted a study using polyphenolic extract of Amla, and the extract was capable of inhibiting the HeLa cell proliferation and stopping cells in the GTM phase, promoting apoptosis, which is cell death, by inducing apoptotic markers. The evidence supporting the activity is still limited, and more efforts are still necessary to clarify the mechanisms involved and explore the effects of Amla for cancer treatment. Anti-inflammatory activity. Amla phytochemistry seems to promote a beneficial effect in the context also of inflammation. An example of the anti-inflammatory action in cell models carried out showed that the cells treated with Amla extract displayed lower levels of inflammatory markers. The modulation of inflammatory markers was also observed at an animal level in a study with arsenic exposure. And in the case of studies involving humans, a randomized crossover clinical trial with type 2 diabetes subjects indicated that the Amla fruit extract decreased platelet aggravation in both single and repeated dose regimens. Digestive tract protection. Amla polyphenols have also been indicated to protect gastrointestinal organs. One of the potential effects of Amla bioactive compounds is the potential inhibition of the Helicobacter pylori strain for ulcers, since this microorganism is a known cause of gastric ulcers. Relevant outcomes were also reported in studies with animals. And the potential of Amla phytochemicals to protect the liver was reported in a study carried out by Hung and others with mice on a high-fat diet induced non-alcoholic fatty liver disease. Another interesting potential health benefit for Amla consumption was reported in patients with gastroesophageal reflux disease. The daily consumption of Amla extract, 500 milligram tablets twice a day, reduce the severity and frequency of regurgitation and heartburn in comparison to the placebo group, and the aforementioned experiments support the protection of organs involved in digestion with Amla phytochemicals, especially polyphenol consumption. Moreover, it seems reasonable to indicate that modern medicine provides partial support to traditional medicine practices with Amla. Neurological protection. One of the potential protective effects associated with Amla bioactive compound is the attenuation of neurological alterations, particularly the biochemical changes observed in carriers of Alzheimer's disease. For instance, the administration of Amla fruit extract for 60 days in mice reduced the neurotoxicity induced by aluminum chloride. Specifically, significant improvement against the triggering of apoptotic mechanisms involving apoptotic protease activating factor with reduced acetylcholinesterase activity in the cerebellum was observed in groups treated with Amla extract. Another relevant outcome reported from the administration of Amla extract in animals with chemically induced neurological impairment is the improvement of memory and learning deficit in different studies. The enhancement of neurological functions associated with Amla was also observed in healthy animals. In this case, the improvements were observed in animals that consumed extracts from unripe fruits at 100 to 200 milligrams per kilogram doses and ripe fruits at 200 milligrams per kilogram, which suggests that neuroactive compounds may be found in unripe rather than the ripe Amla fruits. It's also relevant to mention that the study carried out indicated that some antidepressant possible mechanism of action associated with Amla polyphenols. These authors observed partial inhibition of the antidepressant effect of Amla extract was observed in animals co-administered with aminobutyric acid, alpha adrenoceptor, and a selective D2 receptor antagonist, as well as tryptophan hydrolase inhibitor. The studies reporting the neuroprotective effects of Amla phytochemical support the potential role as assisting agent to attenuate biochemical and physiological changes associated with neurological disorders. Conclusions. The rich phytochemistry composition of Amla can be seen as a relevant source of compounds with potential health benefits. The antioxidant from the rich polyphenol composition is a major property with scientific evidence supporting the direct inhibition of oxidative reactions and the induction of the endogenous antioxidant defense system. Beyond antioxidant activity, it seems reasonable to consider that the current level of evidence that Amla components, mainly the polyphenols, may have a role as supporting source of active compounds to promote health, such as improving antioxidant status in smokers and improving digestive tract protection against stressing agents, and increase the protection against the development of diseases, assisting in the regulation of serum glucose and insulin levels. Although a promising scenario can be seen for Amla, it's important to promote the progression of studies to strengthen the current evidence with more studies, clarifying aspects related to bioaccessibility of bioactive compounds, interaction with gut microbiota, and also exploring technologies and strategies to promote the incorporation into food products, functional foods, are relevant aspects to be explored in further studies.